Greetings! Lab on Tynker Live. This is the show that helps students and teachers make and create with code. We are very excited today because today is the first day of CodeLab Computer Science Education Week. Remember that with Tynker, you can have an hour of code at any time. There are literally thousands of kids watching today from all around the world. We have so much to look forward to in the next 45 minutes. So let's get started. All right, so a little bit about me. My name is Leandra McGriff. I am the Educator Community Specialist at Tynker. Before coming to Tynker, I was an English as a second language teacher where I would travel to different schools in my district teaching English as a second language. And I was also a CS teacher where I got to actually do a little bit of programming with my elementary school students. You can find me on Twitter at Leandra_McGriff. So we really want to invite you guys to tweet this out, share the joy, and invite others to our Tynker Hour of Code activities. Just scan the QR code or go to gotynker/HOC tweet. I'll leave that up there for a couple of seconds. All right, so what are we going to do in today's lesson? In today's lesson, we are going to design a mission patch. And what's really great is that this is like the mission patch that astronauts wear on their spacesuits when they go into space, and you get to personalize it and create your very own. You can also animate your mission patch, which is really nice, and you can do all of that with code. And so we're going to have a fun time doing that with a Tynker specialist. Make sure that you ask questions of NASA. We would love to get your live questions and post it here and answer them with Alicia Batteroni, who is our NASA guest, which we're really excited to have with her here today. So make sure that you ask questions of NASA at gotynker/CodeLabQ. All right, so what's our agenda today? So we are going to get an update on Artemis from our very special NASA guest. Really excited about that. And we're going to understand our project. Then we're going to create with code, and then we're going to do a Q&A at the end where we're going to answer a few questions. Alicia's going to answer some NASA questions that you guys may have. And so make sure that as you do your mission patch, you try to get that certificate of achievement. You'll get some easy recognition just by completing your mission patch, and maybe even a badge as well just for doing so. So definitely do that as well. And now, the moment we've been waiting for, our special guest, Alicia Batteroni. She is from NASA. She is a career STEM educator with 26 years experience creating engaging learning opportunities for students of all ages. She works in the Office of STEM Engagement at NASA headquarters, and in this role, she connects students and educators to the next era of human exploration as NASA works to establish a sustainable presence on the moon and prepares for missions to Mars. She lives in Houston, Texas, where she is an active member of the educational advocacy community for diversity and inclusion. In addition to raising her two sons with her husband, her hobbies include adventure motorcycle riding and growing tropical plants in their garden. And so now we have Alicia Batteroni with us for an update on Artemis. Welcome, Alicia. We're so excited to have you with us today.
Thank you. It's wonderful to be with everyone here today. So I just want to check if I should go ahead and present my slides from my desktop. Oh, you guys got them right there. Perfect. Okay, so I am here to give you an update on Artemis 1, which is a mission flying currently in outer space right now. Very exciting.
It's so amazing.
It really is amazing. I was just looking at live images coming from space, the live video feed coming from the Orion spacecraft, and just some stunning imagery. So I encourage everybody to go check out the nasa.gov website, and you'll see some of those images. You probably see some things on the news, if you turn it on this evening. But Artemis 1 is an uncrewed flight test of our Space Launch System rocket and Orion spacecraft. And it is this system that we intend to use for future Artemis missions, which will provide the foundation for sending humans back to the lunar surface. And not just to go visit, but to really establish a long-term presence on and around the moon and pave the way for humanity to set foot one day on Mars. So let's go ahead to the second slide. This was just a few weeks ago. Orion launched on the Space Launch System rocket from Launch Pad 39B at NASA's Kennedy Space Center, which is in Florida. And this was on Wednesday, November 16th, just a few weeks ago. So let's go on to the next slide. Here, you can see the very first high-resolution image that was taken on the first day of the Artemis 1 mission. So this was captured by a camera on the tip of Orion's solar arrays. And at the time of this photo, the spacecraft was about 57,000 miles away from Earth. And so the spacecraft was on its way away from Earth out towards the moon to a distant orbit of the moon. We are currently on flight day 20, and I'd like to show you some of the beautiful pictures that we got between that first picture and this one. So this next photo that you're looking at is from the 6th day of the mission. It's showing the far side of the moon, which we don't see when we're here on Earth. When we look at the moon, we don't see this side of the moon. And so again, this one was taken by a camera on Orion solar arrays. On November 20th, a couple Sundays ago, we were far enough away from Earth that the moon was influencing the spacecraft's gravity more than the Earth. So the main gravitational force acting on the spacecraft that you see in this image, you can see how close it is, was the moon. It came within 80 miles of the surface of the moon. So that's really close. But there are no humans aboard this spacecraft because this is the very first time we've ever flown it. So we are testing. It's a flight test. We are testing all the systems, the rocket, the systems inside of Orion for humans to make sure that everything is working perfectly before Artemis 2 and we put humans on that spacecraft. So if you look down at the kind of bottom of the image of the moon there, you'll see a dark space. Those dark spots are the seas of the moon. We call that mare. And so that particular dark spot on the bottom there is Mare Orientale is the name of it. Let's go ahead on to the next slide. We can take a look at when we were on this day 6. Well, I said we were within 80 miles of the lunar surface. And so this is a photo from Orion's optical navigation camera. It's a black and white photo showing some of those moon craters. And so these images will allow us to kind of take a check of what the lighting conditions are going to be on the lunar surface for an eventual human landing, and help us orient our spacecraft for future missions when we have a crew. So let's go to the next slide, because I've been showing you a lot of what we see from outside the spacecraft, but this is an image from inside the spacecraft. So this is inside Orion. And you can see it looks like there's a person inside. You're like, but Alicia, you just said there were no people inside. Why is there someone with a helmet there? And so that is what we call, it's a mannequin, or what we like to say at NASA, our moonikin. And our moonikin is there because there's all sorts of sensors. He's wearing the flight suit. And we named the mannequin after one of our pioneers from the Apollo era, Arturo Campos. And he was very instrumental in bringing home a crew of astronauts that ran into trouble on Apollo 13 and weren't able to make their lunar descent and had to be rescued and brought back to space. So that is Commander Munikin Campos. And we are learning a lot about that mannequin flying in space because there are many sensors and data that's coming back from that, that particular piece in the spacecraft. You'll also see in the very middle of that picture something called Callisto. That's a technology demonstration, which is a voice-activated system in the spacecraft that can also change the environment, can change the lighting. So right now you're seeing kind of a blue color. They can change that to a red, to regular color, to green, and create some mood lighting inside this capsule. And then just below that center screen there, you should see the back of a character that flew in the Macy's Day Parade, I think, on Thanksgiving. So I don't know if you can see a little bit of a black ear, wearing this crew spacesuit there. And so if you've been able to guess by now, hopefully you've been able to, that is Snoopy. And Snoopy is flying in the spacecraft as our zero-G indicator. So he's kind of floating a little bit on his side there. So there's a lot more that I could tell you about the inside of the Orion spacecraft, but we're really here to talk about the mission overall. And I want to show you a couple more pictures and then talk about the mission patch. So let's go ahead onto the next slide. And again, this, when I say stunning, like this is a real picture from the spacecraft. So this is flight day 13, where you can see Orion, you can see the moon, and you can see Earth all in the same picture. It's just amazing. It's so beautiful. And so on this day where this picture was taken, Orion reached its maximum distance from Earth. It was 268,563 miles away from home, from Earth. And so it broke the record for any spacecraft that was built for human beings, for it being the farthest away from Earth. It flew farther than any of the Apollo spacecraft had ever flown. So beautiful picture there. Let's go on to slide 8. And so this was yesterday. So you can see that there is some kind of something, you know, to the right of the spacecraft. So I want you to guess, what are we looking at there? What is that? Is that the moon? Is that something else? Is that, what is that? So it looks similar to what we see when we look up in the night sky. It looks like the moon, right? We see sort of a sliver of it when, depending on where it is in its cycle, but that is not the moon. That's actually planet Earth. So that's Orion, again, looking back at home, and it's just gives you kind of a different perspective. When we look up, we're used to seeing the moon, but if you were on the moon, you'd look up and you'd see the Earth. So just imagine if you were one of those first explorers that gets to return to the moon and be one of the, you know, the first to set foot back on the moon after 50 years. So let's go ahead and go to the last slide here now. This is supposed to be animated. I don't know if you maybe click one more, if it will allow you to see the orbit. It looks static, so maybe try clicking on the actual. There should be maybe a play button kind of toward, it's probably hard to see because it's black, but no. All right. Well, I will see if I can share that with the team that you could click on it otherwise, but that is sort of a bird's eye view of, you have the Earth is the blue dot in the middle, pink is the dot is the Orion, and then the green circle around the Earth, that's the moon in orbit around our planet. And so this is just a little animation that shows where Orion and where the moon kind of intersect in their orbits. How just this morning we did a gravity assist slingshot around the moon so that the spacecraft can start its journey back home to Earth. And we are expecting that spacecraft to splash down in just 6 days on December 11th. It will be going 24,500 miles per hour, or Mach 32, as it approaches, comes back into our atmosphere, and it will have traveled a total distance of 1.3 million miles. Pretty amazing stuff. So that's kind of where we are right now on Artemis 1 mission. And on the last slide here, I'd like to talk a little bit about the patch. And NASA, we have a long, long history and tradition of representing the work and the mission of the work of missions through patches, through symbolic representation of different images and colors that tell the story of the mission. And I'm really excited that you'll be able to work on a project to create your own mission patch. But I want you to just take a minute to look at this mission patch for Artemis 1 and notice some of the elements of this patch. What colors do you see? What shapes do you see? What story do you think it's trying to tell? It is very symbolic. It's a historic flight. And so you'll see there is a triangular shape. So give yourself a pat on the back if you said triangle. We've got the colors of, it looks kind of gray on this, but the actual patch, it's more of a silver. So silver gray, orange, red, white, and blue. So give you a pat on the back if you got all those right, if you said all those colors, okay? So this silver highlight around the patch is a nod to the silver of the Orion spacecraft, what it's made of. And that includes our European service module that went on this 40,000 miles past the moon into deep space mission. If you said orange and you saw the flames of the rocket itself and the flames, those flames are there to represent the firepower of the SLS being the most powerful rocket ever built in history. You'll also notice that there are these three little spikes at the bottom of the rocket there underneath the big flame or a big exhaust there. And so those three little spikes represent the lightning towers that are on the launch pad at Launch Pad 39B down at Kennedy Space Center where this took off from. And then you'll see we have these sort of red and blue kind of swooshes around the moon. Obviously, the moon is there. The white moon is proudly emphasizing the journey to the moon. But the red and blue mission trajectories are what those supposed to represent, like the path of the mission. And the colors are there to represent the hard work and the tradition and dedication of this American-led mission, but also a nod to our international partners with the European Space Agency, as both agencies look to work together to forge this new future in space. And so that's about what I had to share with you today. And I will turn it back over to Ms. McGriff and get to more into your program here.
Thank you so much, Alicia. We really appreciate you sharing that update on Artemis and telling us a little bit more about mission patches. That was fantastic. Thank you so much. All right, so now let's get into today's lesson, which is designing a mission patch. And so what can students create? Well, let's go ahead and take a look at what students have created in the past, and let's go ahead and see. So as you can see, the possibilities of creating with Tynker are absolutely endless. Let's go ahead and actually get started. So what you'll do is you'll go, if you have an account, go to www.tynker.com and click the login button in the upper right-hand corner of the screen. And then you're going to log into Tynker as a student. Click the student button. And there you can log in using Tynker, Google, or SmartPass, whatever you prefer. And once you're in, you're going to go to the My Classes tab on the left side, and then click on your class, and then go into Hour of Code. And once you're there, you're going to click on the NASA tab, and then click on Mission Patch, and you'll be ready to start your project. Now, there's also another easy way to access the Mission Patch. All you have to do is go to www.tynker.com/NASA. It'll take you straight to our NASA page where you'll see all of our NASA projects. And there you can just click on Mission Patch and start designing. Now, if you don't have an account, it may not save your work. So make sure that you log in, create an account in order to save your work so you can have access to it later. So definitely do that. Either way works. It's up to you. Those two ways to log in can get you there. So now, without further ado, we are going to bring in our Tynker specialist, Mr. Rizak, who is the senior lead at Tynker. Before coming to Tynker, he was a STEM and science teacher, and he was also a tech coach and director. Mr. Rizak, we are so excited to have you with us today. Thank you for doing this mission patch for us. How are you doing?
Oh, I'm so good. It's very excited. Best week ever for computer science and also NASA, I got to say. Because I've been watching and very excited about the Artemis missions and stuff. So this is going to be a really good chance for students to do. I mean, we've got NASA, we've got CS Ed Week, we've got Artemis. All these great things are aligning all at once. So very excited to show how to make a mission patch.
Absolutely. I will leave you to it then.
All right, my friends. So I'm going to start here. Like Ms. McGriff said, you can go to tynker.com/NASA, and the project is literally right there. I always recommend logging in first, right? Make sure you're signed in. That way, Tynker will save your work, and then, but I think you can do it a lot without being logged in, but you're going to lose your stuff. Design a mission patch is right down here. I have a sample of a really good finished project. And what I'd like to do is take a little bit of the tips from Miss Badaroni and just kind of see kind of where we went with that. Because we created a really nice little animation here. And if I hit play, you can kind of see that, let me go big screen on that, that it moves, the moon is moving. There's a little hand-drawn Orion spacecraft down there. And the text is doing some nice little animations or whatever. It's really fun, right? And it's kind of simple. And then there's there's a text block up there that kind of explains it using the moon and stuff like that. Mine is not going to be that nice, I will tell you that. But I will kind of point you in the right direction as to how we can get started. So if you hit design a mission patch down there, you're going to get your kind of blank project here. And you get your tutorial, and like Tynker always has a nice, model of in our projects about how these should look in the end. And here's that project, same one. But mine, I could go through and actually show you all the code from each one of these. But I'm going to go ahead and just kind of start. So if there's a stage here that kind of just has a nice little background, but there's two different formats of the patch. There's two costumes. So if you hit the gear icon, you can see there's a triangle and then there's a circle. I like the Artemis triangle, so I'm going to go with that, but I could pick either one to kind of get started. If I wanted to do the circle, I could go back here and switch to this costume and do the triangle costume. So from there, I need to kind of add some things to this. And I'm going to start, I think, because, my I'm going to go with my middle school. We were the Lancers. And so I'm going to go ahead and make a mission patch based on my middle school mascot. So if I go to edit that patch right there, I'm going to get the vector, the new editor. And there's a little video that kind of shows you how to use the new vector editor. I'm not going to watch that for you right now. But first thing I want to do is go ahead and just hit the text button, choose some cool text, and I'm going to put the text of my school mascot in here. And I think we are here we go. All right. We are the Lancers. Oh, I'm doing that. Hang on. We're good. Back to my triangle. There we go. I'm going to edit text. I was hoping I could use a kind of a cool font. Lancers. Right. Looks very school fonty, right? Is that right? So I'm going to go to my paint bucket and I'm going to add some color behind that. I think we were green. So I'm kind of creating a base for my mission patch. I'm going to hit save. Green that's a little green, isn't it? Maybe that's fine. That's good for now. It's a little loud, but hey, that's okay. So I have my base. I have my text. I think this is a good way to start. Next is going to be kind of adding animated elements. Now I could go to my add actor button here and I could go to my drawing tool and I could draw a little stick figure man, or something like that, because that's probably about as good as I can do in this amount of time. Or I could add a actor from the media library, which is what I would recommend right now, because I've got so many good media when it comes to space. I've got astronauts, I've got moons, I've got robots, I've got shuttles and things like that. I've got a lot of great things here that I can add. I think adding the moon would be a good idea. I think I might have a moon. There we go. So there's my moon, and I can kind of put that in there. And then I want to have an astronaut. I think I want to put an astronaut in there. So I'm going to go in my media library and pick an astronaut. I need like a single astronaut here. That looks like a good one. All right. So this is going to get us started. Again, I'm not doing this whole project for you, but I'm going to get you started. One of the things I want to do just on the basically is to just animate my actor. So I'm gonna show you how to just do the basic animation here, and I'll zoom in a little bit on what to do. And Tynker kind of works in the way that like an animator would work, in that basically what you can do is kind of create keyframes if you're doing stop motion animation to make your animation work. So that might be one way you can do that. Basically, kind of use an actor that has multiple costumes. And one thing I might do there is go to the settings here, duplicate my costumes, and then I could edit my actor here and just move his arm or something like that, so he waves. I could do something like that, or I could draw here. Gonna move his arm just a little bit like that, and we'll see how that looks here. All right. So, oh no, just for creating a little animation here, just a little bit like that. It looks a little funky right now, but just give it a moment. So I'm going to go back. Now I've got two costumes, one with the hand in one position and the other in another. And if I use that code, this code, the on start forever next costume, we can switch between those. And so our little astronaut man will be kind of waving. Let's do a little shorter on that. Let's test that out. All right. Oh, that's on the patch. We're going to go and bring that down to the actor down here. There we go. Patch, I don't want that there. I'm going to go down here and hit play. All right, so he's kind of waving a little bit, not horribly, but I could improve that. I have another couple of fun little tools in my disposal for making this work and look even better. I have something called the backpack. So the backpack allows me to take objects and actors from other projects and add them, or code snippets. You can see I've added actors. I've done a lot of coding from other projects and stuff like that. So I could make this a little bit more interesting and add some code from another actor or from another project here, which would allow us to, do something a little bit different and make my moon bounce around a little. So there's, again, we're having fun. We're playing around. We're trying some new things and just trying to do some fun animation here with this text. So remember in the last project how they made the text animate. So if you go to this project, this one, and you see how their text animates here in the top right, to accomplish that, there's a, what we're going to do is go and I'll show you, I'll hit stop here. If you look on that and you see that this is the Artemis text, you'll see that in the settings, there's a number of different costumes here. See that? And every costume, you can get some really great animations going, but you have to kind of do the same thing where you go to the end, you duplicate the costume, you edit a little bit, and you can see that with each little bit, they added a little bit of white highlight on top of the text. And that's a neat way to do animation that's really detailed. And you can see how nice that looks up there. If we wanted to try to duplicate something like that, I would have to go to my, I would have to make a text actor down here and then actually start animating that text, or I could just do it in the drawing tool as its own thing. So this hopefully will get you started. Add media, type in some text, add some media here, start to rotate and animate your text. But this should get you started and it should be a lot of fun to get your mission patch off and running. So I'm going to stop there. I don't want to go too far. I want to leave the creativity up to the students, so to speak. But I hope that gets you all started and you're having a blast doing mission patch with Tynker and NASA.
Thank you so much, Mr. Rizak. That was a great demonstration, and I'm sure students everywhere really enjoyed watching it so that they can create their very own mission patches. All right, so let's go ahead and look. We have our Ask Questions of NASA. There's still time to ask a question. Go Tynker/CodeLab Now we're going to go ahead and ask our question to Alicia. We have some here, some preloaded questions from students. So
if you hang on 1 second, I just got some brand new questions from the web, and I'm going to present my screen and show you the updated questions that we just snagged. I think they'll be they're pretty cool. So that
would be amazing.
Yeah, no, they're people must have been listening to you, Ms. Cortez. So question 1 was, how did you get a picture of the far side of the moon? Isn't it always dark isn't it always in the dark, basically, the far side of the moon?
So that is a great question. And the common way to refer to the far side of the moon, we say the dark side of the moon, because to us, that's what it is. But because the moon and the Earth's orbits match each other in a way that we are always seeing the same face of the moon. But the other side of the moon actually isn't always dark. There are some regions of the moon that are permanently shadowed. at the poles, at the South Pole in particular, and it makes that an area of interest to us. But no, it is not always in the dark. And we have a picture of it because we sent our spacecraft out around to the backside of the moon, or what to us is the backside of the moon.
Thank you. That is a great answer to that question. No, that's there's another couple questions in here. I think you might hopefully have answers to. Why did Orion go so far away from the Earth and the moon? So there was a picture you showed that had them going really far. What do you know? Was there a scientific reason for that, or?
Yes. So eventually, our goal is to go far beyond the moon and on to the planet Mars. And so we are experimenting with different orbits, and that was called a distant retrograde orbit, right? To go farther than we've ever gone before, to test out our systems inside the Orion spacecraft, to make sure that we can put humans in that and we can actually push the envelope and really push the edges of where NASA has ever gone before, and to try and achieve those great milestones and achieve great exploration that we haven't done before. So we did it because we want to do it, because we're explorers and we want to see how far we can push it.
Good. That's awesome. Very good answer. Because we can. Why is that mountain? Why do we climb that mountain? Because it's there. All right. Question 3. How did you name the rovers? All right. That's maybe a little out there.
No, that's a great question. We have a whole family of rovers currently on the Martian surface, from ones that are about the size of a small microwave oven to some that are as large as an SUV. And so the names are come up with a variety of ways, the programs that build them, but we've also had naming contests. And I believe the Curiosity rover was named by a student. And so there is a very good chance that we will have a future naming contest related to some of the Artemis components as well. So definitely be on the lookout for that. Maybe you could be one of the students who names the SLS rocket.
Oh, wow. Hey, so there's a question here, and I'm just going to do a shout out before one more question from Pikes Peak School in Colorado Springs. When is the next Artemis mission?
That is another good question. So part of this being a flight test is for us to test everything and see how the systems work and see if there's anything that needs attention, that needs to be changed or fixed or modified for a future human mission. And so the next mission probably won't be for another couple of years while we get all that data and information back from this flight test and have a good look at it and make sure that this system is 100% ready for human beings.
Cool. Well, that's all I have. But I'll switch back to you, Ms. McGriff.
Thank you so much, Mr. Rizak. We appreciate you jumping in there and getting those live questions for us for Ms. Alicia Batteroni. Thank you so much. Well, come to our next show. If you enjoyed this show, we have another show, Coding Cup from BYJU'S. That's our parent company. Tomorrow at 2 p.m. Eastern, you will learn how to create with code your very own soccer team that will be competing against other soccer teams worldwide. So definitely learn how to create your team jerseys, strategize, learn how to create some awesome code so that your team can make it into the top teams competing. All right, that is all for this CodeLab. If you missed a show, go to GoTynker/CodeLab Live 22. And that will be all. Thank you so much for joining us. It's been a pleasure.